This is chapter 11, practice test, and I like to find the keywords to the vocabulary. So right here is the point where a tangent line touches the circle. We've got the word point and we've got tangent. So that's going to be your tangent point. Tangent point, tangent point. That's going to be the point of tangency. So A. Next one, an angle, it's important, whose vertex is on a circle and whose sides contain the chords of the circle. So this is going to be the one that's on the circle, not at the center, so it's not your central angle. It's going to be your inscribed angle. So that's going to be B over here. Half a circle, well, it's a pretty short definition. There's not much else to say. That's a semicircle. An angle, again, that's important, whose vertex is at the center of the circle, that's going to be your central angle. So your central angle is going to be D. A shape that has all its vertices on a circle, polygon. So shape and polygon, so that means E is going to be your answer for that one. And then G, an arc created by an inscribed angle. Arc, that's important. So that's going to be your intercepted arc. If you look at the vocabulary words, that's the only arc that you have. So G. H, the distance from the center of a circle to a point on the circle. From the center is the most important piece here. Remember, that's your radius, goes from the center out. So H is your radius. I, a line intersects a circle at 2 points. Be careful, because there's a segment and there's a line. And the one that's the line that hits that circle in 2 points, that's going to be your secant line. That's I right here for number 5. A segment that is on the tangent line. So a segment on the tangent line is going to be a tangent segment. A segment whose endpoints are on a circle. So this one, it has points on a circle, and it's a segment. That's going to be your chord. Okay, remember, like a guitar chord. Kind of looks like the hole in the center with the chords going through it, with the strings going through it. L, the chord passing through the center. That's a special kind of a chord. Instead of calling it a chord, we call that the diameter. That has to be L. And did we miss one? I don't know how that happened, but I missed F. So F, a line in a plane of a circle that intersects the circle in exactly 1 point. So a line that only hits the circle in 1 point, that is going to be your tangent. F has to be tangent. Here's the vocabulary words, but in a drawing. So a diameter going through the center is going to be either EB or BE. Remember, that's a segment. No dots on the end of that, no arrows on the end of that, just a segment. Number 14, the point of tangency would be point G. That's the only point that the line is touching the circle. A secant would be a line that goes through the circle and hits twice, so that would be over here, DC. Or CD. That one's a line though, so make sure that you put arrows on it. If you don't put arrows, that's not a secant. A chord that is not the diameter, that same set of letters, DC, that's going to be the same set of letters, DC, but it's going to be a segment. It stops, so make sure no arrows or no dots at the end. Name the tangent segment. So a tangent segment would be a piece of this line. So here's your tangent line. The segment could go G to H or it could go G to F. You have to include G. If you don't include G, it wouldn't be called right. So a segment, once again, no arrows, no dots. And then number 18, a tangent line would be that same thing, but now it's the whole line. So if you use the same letters, it's okay. Make sure that you put arrows this time because a tangent line keeps going. Next section, If two chords are congruent in a circle, then the arcs that they create are congruent. And remember, there's a symbol that has an equal sign with a little squiggle on top. That also counts if you want to use the symbol instead of the word. Second one, if the inscribed angle AQB measures 40 degrees, then the intercepted arc AB will measure. Well, if you draw it out, it'll probably make a little more sense. So I'm going to draw just a real quick diagram over here. Inscribed angle is the one that goes all the way back to the circle. It says if the angle is 40, so the angle is 40, then it's asking about the intercepted arc. So this is what you're looking for. Well, remember that if it was in the center, they'd be the same. But pulled back, this is smaller. So if you're going backwards, you're going back to the center. It's getting bigger. That's 80 degrees. 21, if the central angle measures 120 degrees, then the arc AB measures. So if I draw that one out, it says central arc this time. So if this is 120, then this arc would also be 120. Those are the same. So the one that has a central angle, that's going to be the same number. So this is exactly the same. And the one that is the inscribed angle, remember that one, it goes from 40 to 80. That means it's going to double. Number 22, if a chord is a perpendicular bisector to another chord, then the first chord is the diameter. 23, 4, and 5. Arc DE is called arc EFD. EFD, that's the big one, is called the major arc. Actually, arc DE is called it's a small one, minor arc. 25, EC or CD can both be called the radius. If you're talking about each one individually, EC is a radius, CD is a radius. And then together, these are called radii. That's the plural for radius. Okay, 26, the kind I like to call the jack-in-the-box problems, because it looks like jack-in-the-box head if you twist it this way. For the jack-in-the-box problems, these are equal to each other. This segment, this tangent segment, is the same as this tangent segment. So 6x equals 18, divide both sides by 6, x is 3. On this one, because it's showing you that you have a tangent line, and then it tells you, and the radius, then that's going to be a right angle right there. So the radius hitting the tangent line at the point of tangent C. Then that means this is a right triangle, so you can use Pythagorean theorem. So on this one, x squared plus 6 squared plus 10 squared. And then you simplify 6 squared, that's 36. 10 squared, that's 100. Subtract 36 from both sides. Then remember you have to square root it. So if you have a calculator like the ones we have in class, it's second and the x squared button, and that'll give you the square root. And then 64, when you press equal, you get 8. Number 28, another jack-in-the-box problem like 26. Make those equal to each other. So I'm going to have to write it up here. 3x minus 9 equals x plus 15. And then subtract x from both sides. You got 2x minus 9 equals 15. Add 9 to both sides. You get 2x equals 24. And then at the end, divide by 2. And you find out your x is 12. 29. This one is like number 27. Again, we have the radius, we have a tangent line, and a point of tangency. If it's a right triangle, you can use Pythagorean theorem. Again, I'm at the work up here on top because there's very little room in the box. So it's going to be r squared plus 4 squared equals 9 squared. And then 4 squared is 16. 9 squared is 81. 81 minus 16 is 65. And then the square root of 65, a little bigger than 8, is 8.1. Because my calculator gave me 8.0622577748. So rounding to the nearest tenth, like I asked you guys to do, the 6 is going to make that 0 become a 1. On these problems, the length problems are going to be different from the measure problems. Be careful with that. The measure problems are going to be the easier ones because we measure arcs in degrees. The lengths are going to be the ones that are going to take more work. I recommend you save those for after you've done the measures. First one's asking about the measure of arc DE. So DE is going to have the same measure as the angle that's at the center. So it'll be 62. And then if I skip the length for right now and I go to number 32, it says, what is the measure of BAE? BAE would be this half circle, this semicircle, which is 180, and then 38 more. So 180 plus 38 is 218. Again, skipping 33, we're going to save the length ones for later. What is the measure of arc BDE? BDE. Eventually, we need to find this central angle in the middle. But for right now, if we want to know BDE, that'd be this semicircle minus 38. So we can go 180 minus 38. And we get 142. And then it says, what is the circumference of circle C? So it told you that the diameter was 8. And if the diameter is 8, that means the radius is half. It's only 4. So if I want the circumference of the circle, it's going to be 2 times pi times the radius, which is going to give us 25.12. And that means that's the answer for 36, 25.12. Now for all these other problems, I'm going to set up this kind of skeleton so that I know where everything goes. I'm going to put the angle on top of 360. I'm going to be looking for the piece of the circle, and the entire circle is 25.12 because the circumference is the whole circle going all the way around. So the only thing that's going to change on 31, 33, and 35 is going to be the angle that we care about. Because 33 has dB, I'm going to go ahead and find out what this angle is that we don't know. Because we know the semicircle over here is 180. We know between A and B we've got 38. Between E and D we've got 62. So let's find this last little piece. Subtract 180 minus 38 and 62. We get 80 degrees. So the first one says, the first length we need to find is BA. BA was a 38 right there. So I'm going to put 38 right here. You're always going to cross multiply the 25.12 times the angle and then divide by 360. So on the first one, it's 25.12 times 38 divided by 360 is, and that gives me 2.7. Then I do the next one. So on the next one, dB is 80. So cross this off. Now it's an 80. It's going to be 25.12 times 80 divided by 360. We get 5.6. And it would be in feet. And then the last one of these lengths is ED. So where the 62 is, cross out this 80 right here, put a 62. So it'd be 25.12 times 62 divided by 360. We get 4.3. And that would be feet again. This is an inscribed angle. Remember, if it's 110 here at the center, the central angle would have been 110. Pulling it back is going to make it narrower, so it's going to be half of 110. So it's 55 degrees. On this one, it's already been pulled back to be narrower. If we put it to the center again, it would widen that angle up, so it's going to be twice as much as the 85. It's 170. For 39, it's kind of the reverse of 38. So at the center, this would be 220, but you pull it back, it gets smaller, it gets cut in half. 220 divided by 2, we're at 110. On number 40, It's already pulled back. If we brought it to the center, that means we widened it up and it'd get bigger. So that's 112 degrees. On 41, these are the ones that you are averaging the two arcs to find out what's the angle between them. To average them, remember you add the two arcs together and divide by 2. 92 plus 86 is 178, and then divided by 2 is, we got 89. Over here, same thing. The 46 and the 100 get divided by 2, so that'd be 146 divided by 2, so that'd be 73 degrees. It's the same equation, but it's going to be done a little bit differently. So the arcs are still the ones that go on the outside. They're the ones that go on the top. X plus 120 divided by 2. So there's the numerator of our fraction. And then 105, that's the angle that's always supposed to be by itself over here. Remember, you double both sides to get rid of this 2. You have x plus 120 equals 210. And then subtract 120 from the 210, and you find out your x, and this problem is 90. 44, same process. The x and the 125, those are the two arcs. They go on the top of the fraction on the numerator. 105, that's your answer at the other side. Multiply both sides by 2, you get x plus 125 equals 210. Subtract 125 from 210, and you get 85 degrees. Number 45, remember you multiply down the chord, so the 2 goes with the x, the 5 goes with the 6, you get 2x equals 30, divide both sides by 2, you get x is 15. Next one, same thing, multiply down the chord, 4 times x, 4x, 6 times 8, 48. Divide both sides by 4. X is 12. Again, down the lines, down the chords, down the segments. 6 times x, 6x, 4 times 4, 16. Divide both sides by 6. I'm going to go with rounding it. 49. There was a theorem that said that if it's an inscribed polygon, the opposite angles are supplementary. So that means that the x goes with the 89 and y goes with 77, because those are the ones that are across from each other. Over here, you subtract 89 from both sides, and you get x is 91. And on this other equation, you subtract 77 from both sides, and you get y is 103. Number 50, there was a theorem that told us that if one of the sides of a triangle that's inscribed in the circle is the diameter, then that means that going across from that, the angle over here is going to be a right angle. I already know instantly my y is 90. I don't have to do an equation. I just have to know that it's going to be a right angle because this is a diameter, which makes it the hypotenuse of a right triangle. Now that we know that's 90 and we know this is 62, then we just need to find out what's left if we have 180 minus 90 is 90 and 90 minus 62 is going to give us x, which is going to be 28.